This is the WebDAQ homepage, where you set up your data acquisition, as well as view the data in real time on the dashboard. There are some settings configured for you by default, which you can change to configure things such as startup conditions, repeat settings, or stopping your acquisition if an error occurs. To create a new data logging task, or job, I'll click on the plus icon, which will open the job editor. I'll add channels to my job that correspond to the accelerometers I have hooked up to my fan. Channel 0 is reading acceleration in the x direction, and the sensor sensitivity is 175 millivolts per G. Channel 1 is my y acceleration, so I'll label it as such and set the sensitivity as well. Next, I'll go to the Acquisition tab, where I can configure the sample rate and any start or stop settings for this job. The max RPM for these fans is about 6,000, so I don't need a very high sample rate. The settings default to the minimum, and now I'll set the stop condition. There are different options, such as stopping on a trigger or a certain date and time. For this, I'll choose manual to stop the logging when I click the abort button on the interface. Next, we'll configure the logging options. Here you can choose where to store your data file after the job is complete. If you have an SD card or flash drive plugged into the device, you can choose to save the file as there. Otherwise, the default location is the internal storage of the device. I'll name the file fan vibration and leave the option to append the date and time checked so that I have a timestamp in the file for each instance of my job. The final option is to configure any alarms, which I'll come back to later. I'll click Finish, and as you can see, the job has been added to my schedule, and I can see a summary of the configuration options. Let's run the schedule. I can now see that my job is running, and if I go to the dashboard, I can view the values as they're being logged. If I scroll down, I can see a live calculated FFT, whose size is optimized based on your sample rate to ensure a resolution bandwidth of at least 1 Hz. Right now my fan isn't running, so I'm just plotting noise. I'll go ahead and turn on the balanced fan and slowly increase the speed. Now I'm starting to see some frequency peaks, and if I go into the FFT plot settings, I can change the scaling or add a window function. Next, let's see what happens to the data when I switch the input to the unbalanced fan instead. The unbalanced nature causes a lot more vibration, as we can see the amplitude goes up to over 1 G, and we can see additional resonance frequencies on the FFT. I'll go ahead and stop the acquisition now by clicking the abort button. If we go back to the schedule, we can see that the status of our job has changed to completed. Now let's take a look at our data file. I'll go to the Data Files tab, which shows the available storage locations on my device. I save the file in internal storage under the name fan vibration and an appended date and time. Now that I've located the file, I have a few options. I can open the file in the WebDAQ display, convert the data to a CSV or binary file to open in a program such as Excel, delete the file, or download the raw file. You can also upload a file from your computer, such as a previous data file you want to view in the WebDAQ display, or a saved schedule that you want to import. Let's go ahead and display the file here. This shows a strip chart of all the data collected during this job, including a display of my FFT. I can also change my display options to show more or less data at once, as well as change the X values from samples to time. The acquisition details, such as the sample rate, and the job details are available to me as well. Now that I've shown you the basic functionality of the WebDAQ, let's look at some additional features that take this device to the next level. Let's say I want to add an alarm that alerts me when the state of the fan changes from balanced to unbalanced. I can go in and edit my job to add this condition. I'll leave the acquisition settings the same, but I'll change the log file name so that I can identify this job in my files. Next, I'll go to the Alarm tab and add a new alarm. I'll name it unbalanced and choose the type. You can create an alarm based on an analog or digital channel, or you can also alarm based on FFT band power for this particular device. You can set up the FFT size you want to check for your alarm condition, any window function, based on in-band or out-of-band frequencies, and set the power threshold for your alarm condition. I'm going to keep it simple for this alarm and choose an analog alarm based on the X acceleration, and set the condition of the alarm to above 1G. You can also choose what action you want to take when the alarm condition is met. I want to log the alarm to a file. Let's call it fan alarm. You can also set up the alarm to send an email through an SMTP server, a text message, jump to a different job when the alarm condition is met, or send a digital output through one of the device's digital lines. I'm just going to log my alarm to a file and click Finish. Now, if I take a look at my job, I have a new alarm based on when the X acceleration goes above 1G, and the action is to log the alarm to a file called fan alarm. Let's run the schedule, switch over to the dashboard, and see what happens when I turn on the unbalanced fan. Once the acceleration exceeded 1G, the alarm occurrence changed from 0 to 1. I didn't configure my alarm to reset, but you can do that if you want to log multiple occurrences of the alarm condition. Now if we stop the job and go to our data files, I can see the new file for this run, and a text file with my alarm. If I download this file and open it, it contains a timestamp of when the alarm occurred, the job and alarm name, and the value that triggered the alarm. And again, we can take a look at our data in the WebDAQ display. Keep in mind that you can have multiple people view this device in their web browser at the same time, so anyone that needs to view the data can have access to it as long as they're on the same network.